Hey, how do you read a research paper? One of the most important skills that you're going to have as a data scientist, and especially in the machine learning field as it goes forward, is the ability to read a research paper. And it can be intimidating because you've got Greek symbols everywhere. The language is crazy. There's terminology everywhere. Half of it's going to be something that you understand. And no matter how senior you get into the field, the math, the terms, a lot of the concepts that are being covered may be completely new to you. So you need some new skills in order to read a research paper. And the first one is something I alluded to. All of us, doesn't matter how senior you are, look at certain research papers and say, what the? And that's one of the skills that you're going to need is what happens when you look at a research paper and have no idea what it's talking about. In some cases, you need to quickly come up to speed because the research is relevant to the area you're working in. In other cases, it's something that you actually don't need to care about. When you're on the applied side, there are many pieces of a research paper which are interesting, but not necessarily essential for you to understand in order for you to look at the research paper and implement it. So, with that massive preamble, let's do something that I typically do every morning, which is archive. Let's go there. Let's see if I can do this split screen right. Yep, I got it. So you can see this is this morning. This is from Friday. I'm doing this on a Saturday. So this is from yesterday. These are all brand new research papers, at least brand new to archive. And so my first one, you can see how many tabs I have open. I just go down, open them all up, and start looking to see what's interesting about each one of these research papers. The first thing to tell you is that your titles, any of the titles to a research paper are going to tell you very, very little. They're interesting and they may give you a bit of background on what the paper is actually talking about. However, until you get through the abstract, you're not going to know. The abstract, if you're not familiar with research, is the high-level overview of the entire paper. This is essentially what they did, why they did it, and what their results are. And I'm reading it with you, so I apologize if I'm looking a little off center on the camera, but this is me reading a research paper along with you, and I'm going to talk you through it. So this particular paper is about low-rank simplicity bias in deep networks. What does that mean? Well, you're going to go into some papers having no clue what this means at all. You're going to get sent this stuff sometimes in classes, sometimes you're doing your own independent research, and this is going to be the kind of title that you run into. Maybe it's meaningful, maybe it isn't to you. So we start with the abstract, and you're going to end up reading a whole lot of abstracts and then be done. I do this a lot. I will read an abstract and say, okay, well, that's interesting. I might scroll through the paper a little bit and realize, I don't know about this. Maybe this isn't worth the investment of time for me personally to read because it's not relevant to what I'm working on. It's not relevant to the area of work that I do. There can be a number of reasons to look at a research paper and just say, this doesn't apply to me. And the abstract is going to help you figure that out. Even before you get to the abstract, you want to look at all of these names up here. You'll notice there are a significant number of authors. The more authors you see on a paper, typically the better reviewed and the more complete the thinking, because you've had multiple people collaborate. And you'll see all these numbers next to them. What do those numbers mean? Those are citations. And there are references down here to the bottom where I can see, okay, affiliations. That means that some of the authors work at MIT, Google Research, Adobe Research. So these are credible institutions. There is code associated with this project. So it's not just a complete pure theory project. There is some tangible application to it. So as an applied researcher, applied machine learning engineer, anyone that's in the applied side of the field, when you see code associated with a project, you're seeing something that was intended to be implemented in some way, shape, or form. That doesn't mean that you can implement it in production, though. It means that the proof behind this is supported by code and is supported by something that you can run and reproduce. That's a lot of what the types of code that you'll see implemented is. So now that we know this is probably a credible paper, this is a credible paper by credible authors, we can sort of suspend some of our disbelief that you would normally have and skepticism that you would normally have going into a paper. I look at these as well-respected institutions. So instead of coming at this and looking at it as this is probably something that I'm going to really have to do some work on my own to validate, this is something that it looks like has been reviewed well and has likely already gone through a significant amount of validation. So I can have a level of trust that what they're doing in this paper and what they're talking about in this paper fairly supported. Now I'm going to look at the abstract, and the abstract is going to be your friendliest part of the paper, because in the abstract, what the authors intend to do is, as simply as possible, explain what it is that they've done. And in this case, let's see, I'm reading through the abstract. Modern deep learning networks are highly overparameterized. Okay, yeah, they are. Compared to the data on which they are trained, yet they often generalize markedly well. Yeah, you're right. A flurry of recent work has asked, why do deep networks not overfit to their training data? We investigate the hypothesis that deeper nets are implicitly biased to find low-rank solutions, and that these are the solutions that generalize well. Okay, and as I read through, and you can kind of read through the abstract yourself, what this paper is doing is trying to explain a concept of machine learning and a functionality of deep neural networks that isn't very well explored, that isn't very well understood. There are a lot of papers like this. So this isn't specifically something that gives you a new approach. However, this is going to give you a deeper understanding, a better understanding of why a particular functionality of deep neural networks works the way it does. Why does it do this? And you'll find this in a lot of different research papers. There are areas of machine learning and deep learning where models work and we don't really understand why they work. We kind of have this general idea of what's working, why it's working, but we don't, at a very deep, proven level, understand some of the core concepts. And we have a lot of the body of knowledge, a lot of the research that's being done is to understand and to be able to explain why some of these architectures work as well as they do. And that's what this type of paper is. And so it's a great one for you if you're learning and entering the field, because this is going to teach you a deeper understanding of neural networks, which is awesome. Most data scientists don't have this level of comprehension. And this is one of the reasons why you want to read research papers, is because after you get through the abstract, you have this introduction. Now, the introduction is going to talk through all of the concepts and themes that the paper is attempting to cover. This is where papers can get a little bit of intimidating, because you see now we're wandering into the Greek, we're wandering into linear algebra, we're wandering into some of the more complex math. You're going to get into manifolds, you're going to get into some of even complex geometries that underpin a lot of the work that we do. And when you're working in Python, a lot of this is covered for you. Many of these aspects of deep learning models and machine learning models are handled in the background. And so you never see these. You don't get a deep understanding of this. And even if you go through a boot camp, many of the instructors that are teaching you are very, very applied side focused. You won't get this deep of an understanding. So this is intimidating. This is, come on. If you don't have advanced math in your background, this is, blah. Don't be intimidated by it. The first thing I want you to understand is many of these papers are written to be friendly to people that don't understand math, as well as, say, the researchers that are actually doing this. A lot of the time, you can gloss over the math and pick up the concepts, but the math is important. It's sort of a guidepost for you. You need to understand this math as you become more senior, as you become more of an expert. I hate to use expert, but you will become an expert as your career progresses. And this gives you a good guidepost for what types of math you are going to want to dive into more deeply, especially as you read more and more research papers and you become more focused and more specialized as a data scientist. These research papers are going to be key to explaining which types of math are sort of your continuing education. Sometimes you'll see new math introduced in there. it can feel like you are the only one on earth who doesn't know what all of this stuff is, but you're not. All of us at some point struggle. I forget math. And I do this frequently where I have to Google something and go, oh, yeah, yeah, okay. I remember what this is. And it's really the symbology. That's going to be some of the most challenging parts of getting into research and reading research, is that we all talk about the same things differently depending upon what our background is. You'll see this in research papers published in Europe versus research papers published in America. Often the language and the terminology and the complexity of the math in European papers is different than the terminology and the complexity of the math in American papers or US-based publications. Why? Well, they get taught differently. That's just how it is. So if your background's different, even in the same field, if you were taught by a different educational system, or if you come from an economics background versus a computer science background, if you are a behavioral researcher, all of these can tie into making research papers. The language is difficult. Expect to be Googling things. Research papers can be time consuming to go through, but the more that you do, the faster that you can roll through them. Now, even if you're an aspiring data scientist and you haven't gone through all of the classes yet, and you don't necessarily understand everything here, in this case, a lot of what they're talking about with regularization, they say the conventional regularization methods, those are, common concepts. Overparameterization, overfitting, those are all pretty basic concepts. So something like this is accessible. You can read through it even if you don't truly understand all of the mathematical expressions that you're coming across. You can still get through this research paper. Now, what are these? All of these citations. If you're reading something for the first time, a topic or an area of research for the first time, and you've never touched this area before, you're going to want to dig into some of these papers. There are papers that you're going to see cited over and over and over. Like this one right here it's all over the place. This is one of the foundational papers that you'll see cited repeatedly in machine learning. And, again, these right here are good if you want to go deeper into the concepts and understand the roots of this particular field or this particular area of focus. So they're worth reading if you're new to it and you're having a hard time coming to terms with it, because they'll give you more background. If you're not, if these are common concepts, you understand them very, very well, don't worry about the citations. Just worry about the citations around assertions that you don't understand. Why are there so many citations? In the research world, you have to support every assertion that you make with some sort of citation unless you yourself are making that assertion for the first time. And if you do, there is an evidentiary standard. So you're going to have to prove that statement. You're going to have to support your conclusion. And that's a heavy, more complicated version of writing and publication than most people are used to. If you write blog posts yourself or you read blog posts yourself, you'll often see assertions that are made but not supported. We assume things are conventional wisdom. They aren't always, and in many cases, not supporting your assertions can lead to you making mistakes. So in research papers, there's a higher level of rigor. So you'll see these all over the place. You'll see citations everywhere. Now, you're going to go through the introduction, and this is going to give you a very, very good understanding of all of the background, all of the information that you would need in order to understand this paper. This is great if you are not, like I said, not very familiar with the concepts. So read through it, related works. It kind of covered the concepts of what a related work would be. Now we get into some of the more complex math. They're going to explain what they did. Why did I do this? What am I doing? You're going to see graphs and charts, but you'll typically see very, very good explanations of these graphs and charts. Now, as you actually get into the work itself, all of that sort of what I've gone over is a preamble that should get you up to speed so that you can read the rest of the paper with enough of a background to understand what they're doing, why they're doing it, how they're doing it, and so on. Now you dive into the meat of the paper, and this is what's going to take you a long time to read. For you in your early career, I wouldn't necessarily say spend a lot of time reading the body of these papers until you're ready to do research of your own, or until you've had more of a grasp of these foundational concepts. Because this is where it gets very, very thick and very, very intimidating unless you come from a strong mathematical background. Here, in all honesty, this is not very complex math. If you've been in the field for a year or two and you've done sort of the prerequisites in math and stats, most of this math is going to be fairly familiar to you because a lot of this is covered ground. This is well covered ground. And so now they're moving into what they've done, how they did it. Why do they use so much math? Because they have to support all of those assertions, like we talked about earlier. Much of this math is explaining what's been done before, how they adapted what's been done before to this particular application, and what does all of that support. Now we're continuing through a little bit of a background and a little bit of what they've done, how they did it, how they designed their experiment. And again, if you're new to the field, you can scan this, you can read this, and you're going to get, again, a deep, deep understanding of how neural networks and how machine learning works. That's why this is wonderful. However, don't be intimidated by it. If you don't understand something, if you run into something that's confusing, that's complicated, just Google it and don't feel insecure about that. We all do it. Now, rolling through again, more of their work, more of their actual conclusions, more of the meat and substance. So I'm going to go through this quickly because if I spend my time on all of that, this is going to end up being an hour-long video. Now we get to a discussion. You'll often see discussion, conclusion. This is where they talk about the implications of their work. This is important. Now you want to stop here. Even if you're new to the field, you want to stop here because this is going to go back to being more friendly. This is going to go back to being a little bit more of a high level and meant for a general audience to understand. So all of that came earlier, all of the not only prior work, but what they did in this research paper, what does it mean? And they're going to discuss it. In many cases, what they discuss is not necessarily a completely supported conclusion, but they're talking about implications. They're talking about what this could mean. Maybe there's some more work that's going to come afterwards. Maybe there is, this is partial. They could be publishing research before they've completed the full project, but they found something interesting. So the discussion, again, is something that's great for you to stop and start reading over and understand a little bit better. Now you're down to your references. This is what, we talked about earlier. If you're going through and trying to figure out the background for any of the concepts that they're presenting, you'll end up with those links getting pointed down here. Some of these are publicly available papers. Some of them are not. That's hard. Some of these you have to pay for. And so you may be stuck behind a paywall. If you're in an academic setting, if you're actually at a university, many times you can get access to these papers. If you really need them, emailing one of the authors, they'll provide you with the paper for free. So if you reach out and email an author, more times than not, they will email you their paper, and you can get around paying for it that way. Finally, much of the supporting work, you'll notice it was complex up at the top, but in reality, the paper is way more complex, and the supporting work behind it is far more complex. Part of the peer review process will often lead to these appendices and addendums to the paper itself that better support some of the assertions that a peer reviewer may have said, well, I don't believe that is well explained. I don't believe that is well supported. I want you to answer some questions that I have. And these will answer a lot of the peer reviews sort of commentary. Do you need to read through all of these? Unless you have the same questions, no, not necessarily. So it's there. Do you need to read through it? That's questionable. Again, up to your discretion. This is where a lot of the really deep, dense meat can intimidate you. Don't let it do that. Understand from the beginning, even if you are very, very early on in your career, the pieces of a research paper that are scary to you are only scary to you because you haven't encountered those concepts yet. The more research papers you read, the more of these concepts you're going to be exposed to, the more time you're going to spend researching and doing a little bit of background on each one of those concepts, and the more you're going to understand each subsequent research paper that works on the same area. You may be unfamiliar with concepts to begin with when you first start reading research. Don't let that stop you. Don't let a piece of the paper that doesn't make sense to you stop you. Write it down, put some notes down off to the side, and just say, look, I'm going to come back to this later. If it's a core piece of the paper and you really can't understand the paper without it, you need to spend some time. And that's why I said reading research papers can be a time-intensive process. So there you have it. That was a research paper. We read through it, scanned through it. I gave you the process of going through a research paper and talked you through what each one of these areas and what you're going to expect to see in a research paper is. Next video, we're going to go a little bit deeper. We're actually going to read through a research paper, and I want to show you, if I were in your shoes, what I would do, and I want to make it normal for you. I want you to feel like all of us do this, because we really do. We Google, we have to look things up, but there are some complexities here. How do you Google math? That's hard. So we'll take a deeper walk through another research paper that's a bit more obscure in the next video. And in a third video, I'm going to help you understand how to figure out which research papers to read, because there are hundreds published every day. So how do you create a filter to understand which research papers are worth your time and which are interesting but not actually applicable to you? So I'll see you in the next videos.